right. 5-6, last section of topic 5 is called inverses of functions. So an inverse is when it's something that undoes a function, right? So adding undoes subtracting, multiplying undoes dividing, so forth and so on. An inverse is the function that undoes the action of the others. When we are looking at something like a table, such as our first example from the workbook, page 260 if you have the workbook. Otherwise, just take notes on your own paper. All we do is flip x and y. So before we had the point -1, 9. The inverse is going to be the point 9, -1. So they're just going to flip. So 9, -1. Flip to 7, 0. Flip to 5, 1. Flip to 3, 2. Flip to 1, 3. And then flip -1, 4. Okay. So when given a table or given points, it's really easy. All you do is flip x and y. Just switch them back and forth. Okay. I could plot those points on a graph too, remember. You'll see soon. All right, what if we did 2x plus 1? If we want to find the inverse, first thing we're going to do is switch x and y. So step 1 is always switch the x and y. Remember that f of x is the same thing as y. So we're then going to have x equals 2y plus 1. So this was y. I flipped it. Okay. This was x. I put it where there was y. So I switched them. Okay. Step 2 is solve for y. So we're going to practice our solving skills doing PEMDAS backwards. Okay. So is there something on the outside being added or subtracted that I can move over? The answer is yes. There's a plus 1. Okay. Then move up the ladder. Is there something being divided or multiplied that I could undo or do the inverse of to divide? Yes. Okay. Now I have y by itself. So that y equals x minus 1 over 2 is the inverse of 2x plus 1. Okay. What does that look like on a graph? So I used Desmos, if you can tell. So remember, you can just go to desmos.com to find this. Here are the points that I got from it. If I wanted to graph the inverse, I'm just going to flip those x, y points. So all of those numbers, I am just flipping to the other side. Okay, so -3, I'm going to actually change my color here because that looks a lot like the color it is. All right, so -3, -2, -1, -1, 1, 0, 3, 1, and 5, 2. So my inverse, when graphed, looks like this. The secret is that whenever I have an inverse, they always reflect over the diagonal. That diagonal is actually called y equals x. And if I were to fold that sheet of paper on that dashed line, the red line would touch the blue line. Okay. All right. One additional example and we're done with notes. This is not in your workbook, so just cross out something in your workbook and put this instead so you can pause to write it down, but I'm going to keep on going. All right, so if I want to find the inverse of this, I'm going to switch x and y. Remember that squaring something is the inverse of square rooting something. So that means that I need to square this to try to get y by itself. Okay. And then the last step to get y by itself is this. Okay. All right. The second part of that, it wants to know domain and range of the function. To save us a little bit of time, I'm not going to show you me graphing this on Desmos. However, feel free to graph that on Desmos if you do not believe me that this looks like this graph when I graph it. It's 7 over, okay? So that means that my domain starts at positive 7 and goes on for infinity. So we say x is greater than or equal to 7. The range is the bottom to the top. So the bottom is at 0, so y is greater than or equal to 0. Now, here's what's awesome. The inverse function's domain and range is just the opposite. So what do I mean? I mean, it's still, domain is still x, range is still y. But this will move right here. And this one will move right here. So my domain for the inverse is x is greater than or equal to 0. My range for the inverse function is y is greater than or equal to 7. So they just flip-flop. Okay. All right. There's a quick video on the highlights of inverses. Next up is practice.